Welcome to this special episode of Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle, and today I'm talking with Eric Versluys, Director of Defense Programs at Fortify. Welcome, Eric.
Hi, Pat. Thanks for having me on today.
So, additive manufacturing has kind of been revolutionizing many sectors. So, I thought it'd be great to discuss how it's affecting the aerospace and defense industry. Looking at the overall market, how will defense manufacturing change in the coming years to meet domestic supply chain requirements?
Yeah, I think one of the big priorities that we're seeing right now is the ability to scale. And with the war in Ukraine, kind of drawing down on the stocks that we have in our military, even though we're not actively involved, and then rising conflicts around the globe, especially with China and the South Pacific, we're seeing that our industrial base needs to be able to scale up in volume and capacity, which we do not have the same industrial base that we could rely on that we did back in the 1940s when we got involved in World War II. And I think it's important to note that additive manufacturing, with the ability to scale and iterate, is going to provide a key tool set for us to be able to meet those challenges with new technologies that have either the ability to, like I said, iterate through learnings in the battle space as we progress, and also with the ability to bring new capabilities to bear really quickly.
Yeah, you can see there's a definite need with several countries supplying Ukraine and still struggling to keep up at times with certain munitions. So, what are some of the current limitations in the defense and aerospace industry technologies that additive manufacturing can help address, especially in the RF and microwave applications?
One of the things that we've seen at Fortify and seen throughout some of the RF systems that we're particularly looking at is the cost is astronomical. So the ability to get the cost way down is going to be critical, especially as we're looking at proliferation of unmanned systems around the battle space. I think it's important to mention that Secretary Kendall has laid out a plan to field, 1 to 2,000 collaborative combat aircraft that will be flying around with manned platforms within the next 10 to 15 years. And in order to get that sort of scale on the battlefield, we need to get the cost way down while not sacrificing performance. And that's really some of the areas that we're focused on here at Fortify.
And with the rise of 5G and the commercial space markets, how does millimeter wave communications benefit from the defense and intelligence sectors?
Yeah, looking at multiple domains here. So in space, through aerospace, even ground-based, millimeter wave really enables a lot more throughput of data. We can bring a lot more data around the battle space through these multiple domains. The chief technologist of CENTCOM just a few days ago said that AI is basically dead unless you have those networks to be able to pass data around and be able to provide the warfighters with the information that they need on a timely basis. And so taking some of the learnings in the commercial space, and you see Starlink is being actively used on the ground in Ukraine, and types of systems like that will become, critical infrastructure as we move forward into the 21st century. So that's where the commercial market really can be applied to defense, is being able to use the millimeter wave technologies to increase throughput, increase data, and get that data where it needs to be quickly.
Yeah, and Fortify has been involved in additive manufacturing for many years. Can you give us some examples of the RF and microwave products that you're enabling with the technology?
Sure, we've got a couple good examples. So the first one was a customer who came to us who had an integrated RF system that they needed to increase performance and increase gain at the bore site of this particular antenna. And so instead of requiring a re-architecture of the entire system, taking out the RF antennas and front ends and all the back end stuff behind the antenna, we were able to just apply a grid lens in front of this and increase the gain where it needed to be, without a huge impact on the platform itself. Another good example is a project we're working on with Rogers, where we can take a phased array, and by applying a grid lens in front of this phased array, we can get full horizon to horizon steering from a phased array. So we are able to use this lens to increase the performance of the phased array and get better coverage than you normally would with just the antenna itself. And then third, and this is an exciting one that we have kind of in the works right now, we are looking at using grid lenses with switched beam arrays. So instead of having the cost and the power requirements that you would typically incur with a phased array system, you can get similar performance out of there for a tenth of the cost, a tenth of the power required, and still equivalent performance. So pretty exciting stuff that we got going on right now. And those are all examples that have real parts that have been built and have been tested.
Yeah, that's pretty impressive that you can just add a lens to a system like that and improve the system performance immediately.
Yep.
So, what future improvements do you see on the horizon for additive manufacturing for defense and aerospace applications?
I think the next area that we're really looking at, and this is where some of dielectric additive manufacturing really comes into play, is in some of the extreme environments, whether it's space or hypersonics, areas where there's manufacturing technologies, or we're lacking in manufacturing technologies to go produce materials in these extreme domains. I think that's kind of the next step for the additive manufacturing RF market, and this is where we can bring some new technologies and applications perspectives to these challenging areas and go do some things that'll kind of flip the systems on their heads. So that's what we're excited to work on.
Well, I can't wait to see those develop. So, thank you very much, Eric, for talking with me today about additive manufacturing and 3D printing, how it's affecting the aerospace and defense industries. This technology is evolving quickly, so we hope to have you back for those updates. To our audience, you can find more videos at videos.microwavejournal.com. Thanks for watching.
Thanks, Pat.